Okay, so today we're going to talk about macros in C++. It is one of those features that sort of existed since day one, and the reason for that is because that it directly inherits it from C programming language. But it is one of those very troublesome features in C++ and the source of many evil. And you are sort of strongly discouraged to use macros in your CPP applications. And there are like trillions of reasons for that. We're going to mention a few in this video. But then you might be wondering, like, why the heck are you making this video then? The only reason that I'm making this video is because that there is like huge amount of sort of large code bases out there which still use macros and rely on macros. If you happen to be sort of, developing one of those or working on one of those sort of code bases, you're more than welcome to watch this video to know that how macros work and what macros are essentially. So we're going to start with the first problem of macros. We have a subset of sort of a standard macros, sort of these large compiler vendors such as Clang, GCC, MSVC compilers, they sort of tend to define them. Something like file. They always start with sort of a double underscore, which basically this macro dumps the source file that you're working with. For example, if you have an error somewhere in your application, you can say, hey, at this CPP file or at this .h file, this error happened at this line number. But there's also a huge list of sort of macros which are completely system dependent or compiler vendor dependent. And that is, if you use them, then you're going to have some portability issues, unfortunately, right? So on my machine, for example, I can say CPP, this is the C preprocessor. I can say -D capital M. And then this is the pattern, in file, out file. If you don't want to pass an in file to preprocess, you can say dash, but this means that it's going to take it from the standard input. So I'm going to give it a dummy sort of input. And for the out file, I can simply say, hey, dump it into output. Take a look at output. It's like 768 predefined macros on my machine. First thing you learn is that if you want to define a macro, you're going to say pound define, and then you have the name of the macro and the value associated to that. So let's jump into my main function. Before defining a macro, this pound include is not a macro, but it's sort of a preprocessor sort of directive. All it says that, hey, go and find this standard library and copy and paste everything in there to this, let's say, above this main function. Let's take a look at this. If I say the standard should be C++11, and then capital E, I want to take a look at my preprocessed version. If I say output, take a look at output. Now you see that simple sort of application, the main function which returns 0, expanded into 44,811 sort of lines of code, and whatever you see above this main function is basically IO stream. Okay, so let's define some funky macros. You can say define, and then something like begin, and you can say, hey, int main, and then open curly brace, and define sort of end return 0, and then close this. And then I can remove everything here basically, and I can say, hey, begin and end, just like that. And in between, I can even say std out something like, I don't know, hello. If I do this, this is completely valid code. Take a look at this output. Whenever the preprocessor sees begin, it just copies and, pastes everything there. Here it sees end, it pastes everything there. So this is sort of literally a textual substitution. So now you can manipulate your source file down to the token level, basically. And this is completely valid. So you can, if I remove this thing, you can compile this and you can run it and you see, you get hello. I promised you that I'm going to talk about reasons that you should not use macros. So let's start with it. There is no respect to reserved keywords in C++. What does that mean? It means that if I come down here, if I say int friend, which is a reserved keyword in C++, int friend equals 4. You see that clang is telling me that, hey, friend use outside of class. Clang is sort of confused, but it's indirectly telling you that, hey, friend is sort of a reserved keyword in C. You can't use it to define a variable. But there is no such limitation for macros. You can literally say, hey, define friend, and friend is going to be D, for example. Now you see that clang is happy because it's literally, as I say, int D equals 4, and this code is compiling fine, and you can run it fine as well. I can even sort of print this friend variable that I have right there. Compile, run, you see that 4 is being shown. The only keywords that they can get away out of sort of macros is the keyword, or not a keyword, the word defined. If I say define equals, for example, 34, you see that Clang is complaining. It says define cannot be used as a macro name. And the reason for that is define is sort of a keyword that you can use inside conditional statements for preprocess. So you can say, for example, hey, pound if defined, for example, friend, then do something for me. So that is why you cannot use define. Other things in C++ are sort of some operator names, such as, for example, and. You can't use this one as well. You see that Clang is telling you that C++ operator and aka ampersand used as a macro. You can't do that. These are the only sort of limitations. Otherwise, you can use any keyword in C++, and then you can basically, ruin everything. Another reason is that there is no respect to type safety in C++. For macros, of course. If I say, hey, define find max, sort of something similar to a function, gets two input arguments, and all it says is that, hey, if A is greater than sort of B, question mark, then return A, otherwise return B. And then down here, I can say find max. I can feed in my friend, and for example, J, which I am going to define J right here, which happens to have the value of 5, for example. Okay, if I compile and run it, of course, I haven't said here that I want to print the result of this. std cout this thing, and std inline. If I compile and run it, you see that 5 is getting printed, and that is indeed actually the maximum between 4 and 5. But if I come down here and I say J is a double, you see that Clang is completely happy. I can compile this and I can run it. So there is no type safety here. The alternative that C++ language sort of suggests to you in this case is simply using templates, for example. You can say template type name type, and then you can say, hey, type find max, and type A, type B, and then do the same thing. Return A greater than B, question mark, return A, otherwise return B. And in this case, if instead of this find max, if I say find max, this is sort of the template function version of it, you see that Clang is complaining. Why? Because it says no matching function call for this. And the reason for that is because friend is integer, but J is a double. So there we go. There's no type safety. There's no limitation, no sort of boundary for macros. The next thing is there is no respect to scope in C++ with macros. What does that mean? You know that we usually use namespaces to sort of avoid name conflicts in C++. I can say, for example, namespace my name, and I can, inside this, I can say int value equals, for example, 4. And then if I come outside in the global scope, if I say int the same thing, int value equals 6, it's completely fine because we have namespaces for such conditions, right? Two variables with the same name but different values, but there's no conflicts. You see that Clang is completely happy. But if I take this thing and I define it as a macro, if I say, whoops, define, and then I say value as, for example, 6, you see that all of a sudden Clang is unhappy because it says that, hey, expected unqualified ID. So there is actually no scope for macros. If you define this thing here, you know, then you're basically reassigning it into something else, into your namespace. So there's no scope. This is another sort of reason that you should not use macros. What else? We have no respect to evaluation sequence in C++. For this one, you can define, for example, define a simple square function that takes an argument x, and what it does is that x multiplied by x. If I go down here and I say, for example, std cout, and I want to say, hey, square, what is the square of j? I want to know that. Let's get rid of this one and this one. I want to know the square of j, which was 5, right? If I compile this and run it, square of 5 is 25, right? But what if I come down here and instead of j, I say j plus 1? So you might be saying that, hey, 5 plus 1 is going to be 6. 6 times 6 is going to be 36, right? Okay, let's take a look at it. What the heck? 11? Why this is happening? The reason why this is happening is simply because, as we said, like, it's just textual substitution. You're saying that for x, you're going to say j plus 1 multiplied by j plus 1. And what is j? J is actually 5 and 5. And you know that multiplication has a higher precedence compared to subtraction and addition. So 1 times 5 is going to be 5, plus 5 is going to be 10, plus 1 is going to be 11. So that's why you're getting 11 out of that. So there is one solution for this, and that is to guard your, basically, and that is why I also put so many parentheses here as well, but I didn't say the reason. So now if you compile this and if you run it, you see that the value is 36 actually. But there is, so this is one solution, but there is no workaround if you say, for example, j++. Then you're going to be in deep trouble because, so plus means that j is going to be, the first time it's going to be 5, then the value is going to get increased, it's going to be 6, and then 6 is going to be here, and then the value is going to get increased to 7, but it's going to be 5 times 6, it's going to be 30. But you expected what? You expected, for example, to get, I don't know, if it was like plus j, it's going to be 6, and 6 times 6 is going to be, so here 6 times 6 again is going to be 36. But here we have the problem of sort of double evaluation. So if I compile this, at least we get a warning. But you know, you can say, hey, I don't care about warnings. You get 30, as I said. 5 times 6 is going to be 30. There we go. So tremendous, at least a few sort of reasons that why you shouldn't use macros in C++. But there we go. This was sort of a crash course on macros in C++. I hope you learned something from this video and hope to see you in the next one.